Hello, good day. How are you today? You're good, right? Okay. Are you ready for today's lesson? You are? That is good. So today in mathematics, we are going to be looking at sword. Okay? Our topic for today in mathematics it's on sword. So are we ready for the lesson? We're with our books, our pencils, or pen to get into today's lesson, right? So before we look at the meaning of sword, we're going to be looking at rational and irrational numbers first before sword, okay? Rational numbers include integers and fractions, okay? Integers are whole numbers and their negative counterparts. Whole numbers 1, 2, 3, 4, 5, continuously, 6, 7, 8, 9, continuously. Then the negative counterpart is -1, -2, -3, -7, -10, -100, okay? And fractions, which we have here, 3/4. 3 and 4 are integers, right? So rational numbers are like whole numbers, okay? Now, irrational numbers include the square root of non-square integers like 2, square root of 2, or square root of 5. So irrational numbers are numbers that cannot be expressed as fractions, unlike rational numbers. Irrational numbers have non-repeating or non-terminating decimal expansions, okay? These numbers go on forever without repeating after the decimal point. Do you understand? We can't get the square root of 2, okay? We can't get the square root of 5. The square root is not a whole number. The square root of 2 is not a whole number. The square root of 5 is not a whole number, okay? We can get the square root of 4. The square root of 4 is 2. 2 times 2 is 4, right? You can get the square root of 25. 5 times 5 is 25, so the square root of 25 is 5. But you can't get the square root of 2. Do you understand? So sword falls under irrational numbers, okay? Swords are mathematical expressions containing square roots of irrational numbers. Do you understand now? Sword is the square root of irrational number, and that irrational number must be positive, okay? That is sword. Do you understand what I'm saying? All those numbers, all those square roots that cannot be simplified as whole numbers, they are termed as sword, okay? When you look for the square root of 2, it's not a whole number, it's a irrational number, right? When you look for the square root of 3, it's not a whole number. You look for the square root of 5, it's not a whole number. You look for the cube root of 5, it's not a whole number. Do you understand what I'm saying? Now, if you look for the square root of 4, you will find out that the square root of 4 is 2. So that is not a sword, okay? The square root of 4 is not a sword. The square root of 9 is not a sword, because the square root of 9 is 3. 3 times 3 will give you 9. But you can't find the square root of 2 as a whole number. Do you understand what I'm saying? Good. So here we have the cube root of 3. This place that contains 3 is the order. In a sword, this is called the order, okay? It is called the order or the index. Do you understand? And the order has to be greater than 1, okay? Then this sharp side, which is the root sign, is called the radical, okay? This place, the sharp side, is called the radical. This is the root sign, right? It is called the radical. okay? And the number inside the radical, which is 5 here, the number is called the radical or base, okay? So this is the order, this is the radical, and this is the radicand or base. Do you understand? So the irrational root of a positive rational number is called the surd, okay? Remember, the answer has to be in irrational and the radicand or base has to be positive rational number, okay? So we're going to be looking at some basic operation like addition, subtraction, multiplication, division, and so on. Okay, are we ready? So let's look at addition and subtraction first. Now, when adding or subtracting surds, ensure that the radicals are the same, okay? 2 root 3 plus 3 root 3. You can see the radicands are the same, right? You collect like terms, okay? This is already like term, so 2 plus 3 is going to give you 5. Okay, you add the others together. 2 plus 3 is going to give you 5. So we have 5 root 3 as our answer. Do you understand that? You can see our answer is an irrational form, right? Now, let's look at subtraction. We have here 5 root 7 minus 2 root 7. The same way with addition, okay? The radicals are already the same, so you subtract the other. So 5 minus 2 is going to give us 3, so we have 3 root 7 as our answer, okay? I hope you're not confused. So when adding or subtracting surds, ensure the radicands are the same, okay? Now let's look at multiplication and division. To multiply surds, simply multiply the coefficients and multiply the radicands, okay? Like this, we have 2 square 5, 2 root 5 times 3 root 2. You multiply 2 times 3 and multiply 5 times 2, okay? 2 times 3 is going to give us 6 and 5 times 2 is going to give us 10. This should be times, not plus, okay? So 2 root 5 times 3 root 2 is going to give us 6 root 10, okay? Do you understand? Good. Then in division, this is division, right? It's over 4 root 7 over root 2. When dividing surds, rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of the denominator. Do you understand? I hope you're not confused. How do we rationalize this? The denominator here is the square root of 2, right? So we are going to use the square root of 2 to multiply the numerator and also the denominator. That's why we have here the 4 root 7 over square root 2 times square root 2 over square root 2, okay? So this square root cancel this square root and we're left with 4 root 7 times square root 2. There is no 4 to multiply the other here, so we have 4 here and 7 times 2 is going to give us 14. So our answer is 4 root 14, okay? So rationalizing this will give us 4 root 14. Do you understand that? I hope you're not confused. So I'm sure if we see surds, if we see addition, subtraction, multiplication, and division of surds, you'll be able to attempt it and have a good answer, right? Okay, so next we're going to be looking at conjugates of binomial surds. The conjugate of binomial surds is obtained by changing the sign between the terms, okay? What do we mean by binomial surds? There are two surds, okay? Two surds. Now, we are going to be looking for the conjugates of binomial surds, and the conjugate of binomial surd is obtained by changing the sign between the terms. Here we have a plus b root 2. To get the conjugate of this is to just change the sign, okay? You change this plus sign to minus. So the conjugate of this is a minus b root 2. Easy peasy. Okay? Let's look at an example root numbers. Here we have 2 plus 3 root 5 is equals to what? The conjugate of this is 2 minus 3 root 5. You just have to change the plus sign, okay? So 2 minus 3 root 5 is the conjugate of 2 plus 3 root 5. Do you understand? Now we also have here bracket a minus b bracket close raised to power 2. How do you write this? This isn't 2, right? There are two terms here because it's raised to power 2, so this isn't 2. So you write it as a minus b bracket open bracket close bracket open a plus b bracket close, okay? This is a conjugate of this and this is a conjugate of this, okay? If you want to simplify this, a times a is going to give you a squared plus a times b is going to give you ab. Minus b times a is going to give you minus ab, and minus b times b is going to give you minus b squared. So ab minus ab is going to give you nothing, so you are left with a squared minus b squared. This can be simplified as bracket a minus b bracket close raised to power 2. It's still the same thing as this, okay? Are you seeing? So this is how to get the conjugates of binomial surd, okay? You just have to change the sign between the terms, okay? This is a term, right? You change the sign. Okay, do you understand? No confusion here, right? Okay, that is good. So today's lesson on surd, we understood everything we talked about, right? We looked at the meaning of rational and irrational numbers and also surd. Then we looked at basic operation on surd, right? We looked at addition and subtraction, which I'm sure by now you'll be able to do, right? We also looked at multiplication and division, which you're able to do now. And lastly, we looked at finding the conjugates of binomial surds, right? So today's lesson, we understood everything we talked about. Okay, that is good. So next we're going to be looking at our assignment. I'm sure we're going to be able to solve this, right? It's going to be easy for us, right? Okay, that is good.